Welcome. Mr. Scarf has paid me a lot of money to give you guys this presentation, so feel free to take notes. That is a complete joke. Mr. Scarf is not paying me. You may be wondering why I'm wearing a lab coat, and the reason is that if you're wearing a lab coat, you are 10 times better at calculus. So hopefully this is good luck for this lesson. This is a lesson on the applications of calculus. So we've all been in calculus class wondering what we're doing and how it can be applicable. So this is one of the most obvious applications of calculus, and I'm going to start with an example. So say you have a function that looks something like this. So typical cubic function, and you want to find your critical points, so your extremes. So you have a local extreme here and a local extreme here. So a local maximum here, because it's a maximum, but it's not the full maximum. It's a local maximum because it's not for the entire function, it's just for one area, and a local minimum. So we can use the derivatives, which tell us the slope of the tangent. We can use that to help us find these points, because if you look at a point as it's approaching this local maximum, that's going to be the slope of the derivative on that side. And on this side, the slope of the derivative, or the tangent, the slope of the tangent will look something like this on either side. But directly at the point, directly at the local maximum here, or the critical point, the slope of the tangent is going to be 0. So the slope of the tangent is 0 at a maximum point. Now this is a very, very important feature of calculus and has a very specific application in business, as we're going to look at right now. So in business, this concept of finding extreme points can be used to optimize revenue. So this is a branch of calculus called optimization. So if we look at this example right here, the production of cat sweaters at Snuggles Kitty Boutique is modeled by the function r of x, so revenue in respect to x, where x is the number of cat sweaters sold, is negative x cubed plus 450x plus 52,000x. So the question is, what production, so how many cat sweaters will you have to sell to yield the maximum profit? So how many cat sweaters will we have to sell to make the most money, which is a very important question. So the first thing we need to do is set a domain. So when you're talking about revenue, your revenue is only going to be greater than 0. So we need to find when this function is greater than 0. So we need to establish a domain that makes sense for this question. So the way we do that is we're going to write out the function. And write out the function, again, x cubed plus 52,000x. And we're going to try to find out when that's greater than 0. So in order to do that, we need to find our zeros. So wherever it crosses the x-axis, whenever it's greater than that value is what we'll use for our optimization. So we can factor this. These all have an x in it. So we can take that x out, and we're left with negative x cubed plus 450 squared plus, this would be x squared plus x plus 52,000. Okay. So we know that this x here will be 0, so that makes sense. So if we start from no cat sweater sold, I've already solved this. I've for the sake of making this video as short as possible, I've already calculated the other zeros for this question. So you have an x value here. So if you were to factor this in here, using just simple factoring, you would get one value of x equaling to 545 and another x value to equal negative 95 approximately. So we can neglect this negative 95 because we can't sell negative cat sweaters. So we're never going to need to use this negative 95 because at no point will we need to sell less than 0 cat sweaters. So we can neglect that. So what we're left with is a domain between 0 and 545, which makes sense based on the question. So our domain will be x is greater than 0, but less than or equal to 545. So now that we've established the domain, we can start to our first steps to optimizing and finding the optimal production value. So I'm going to rewrite the domain up here. So x is greater than 0, x is less than or equal to 545. So the next step for an optimization question such as this is we need to find the derivative of our revenue formula. So we rewrite the formula. So to find the derivative of this, it's extremely simple. So we're going to take this 3, put it out in front. So our r prime of x. So this is just simple derivative. So we're going to take that 3, put it out in front, and then subtract the exponent by 1. And then we're going to do the same thing for here. So we're just going to take the 2 out in front. So this would become 900x, and then this would become 52,000. Okay, so now we come to this step. Make this more clear that this is the derivative. R prime of x. So this is r prime of x. So now that we found our derivative, we know that the slope of the tangent at a critical point is equal to 0. So all we need to do is set our derivative to equal 0 and then solve for x. So again, I've gone through the liberty of solving this and factoring this out. So we can factor out a 3, negative 3. We'll just leave this with x squared minus 300x minus 17,500. And then we just factor the inside the same way we factored the inside of the previous function, just through simple factoring. So this comes out to x minus 350 times x plus 50. So you can FOIL this thing out and you'll get this. So just simple factoring. So from here we can conclude that x is equal to 350 or x is equal to negative 50. So again, like we discarded the negative 95 earlier, the negative number here is not helpful to us, so this is a negative 50. It's a negative 50 right there. So we can neglect this negative 50 because it doesn't make sense in the context of the question. we don't need it because you're not going to sell negative cat sweaters. So we can take away that 50. So we know that there is a critical point at 350 cat sweaters sold. However, we're not sure if that critical point is a max or a min. A max and min can either occur at a critical point inside of a function, or it can occur at one of the endpoints of our domain. So what we need to do at this point is we need to take these 3 values, so 350, 0, and 550. We put them back into our revenue formula, and we solve for the revenue. So whichever revenue is the highest is the maximum. So x equals 350, just so we can remember that. So if we do r of 0, so if we find the revenue at 0, that's going to equal negative 0 cubed plus 450 times 0 squared plus 52,000 times 0. So 0 plus 0 plus 0, that's going to equal 0. So r at 0 equals 0. Now, r at 350 equals negative 350 cubed plus 450 times 350 squared plus 52,000 times 350. Now, you're going to have to trust my algebra because I'm not going to go through each step because they're rather large numbers. So this value comes out to $6,937,500. So, oh sorry, that's 69,037,500. So a rather large number. So let's see what R at 545 is. So that's going to be negative 545 cubed plus 450 times 545 squared plus 52,000 times 545. So this value comes out with my algebra, which hopefully you trust, and I trust as well, comes out to 122,625. So if we compare these values, 0, 122,625, and 69 million and some, it's clear that 69 million is much higher than the other two values. So in this context, we have a local 50 because this value is the highest. So we know, hopefully you've copied all this down. So now we know for a fact, by comparing the endpoints, that within this domain, that if we sell 350 cat sweaters, we will maximize our revenue. Thank you.